Guys, today I'm going to be talking about questions number 4 and 5, and maybe some things in between that. But just going to go ahead and get started here. Number 4, compare the probabilities from your prediction, question number 1, to the observed frequencies, question number 2, the yellow numbers. Construct an explanation for why the measured frequencies either match or do not match your prediction. Use the graphical representations and the calculated frequencies to support your explanation. Discuss the role natural selection may have played when explaining why the frequency of traits in the bacterial population may have changed over many generations within the environment of the petri dish. So pretty much, guys, the question's asking this. Looking at your answer to number 1, question number 1, and we'll scroll up and take a look at that, where it said that none of the traits provided a reproductive advantage. So meaning none of them being better than the other ones. What do you expect to happen? And in that answer, what you should have said was something along the lines of that since none of those traits provide any of those bacteria any advantages over the others, when you look at time 4, the percentages should be very similar to one another. It should probably stay 25%, 25%, 25%, 25%. Whereas we know that doesn't happen. Okay. And number 4, you should be explaining that by looking at the data, by calculating those frequencies here in the yellow, even though these are still wrong. They should be 43%, 33, 11, and 13. When we look at those, you see that 1 or 2 of the different traits worked better than the others, and the other 2 did not work as good as the other ones did. So you should be able to say in question number 4, you should be able to show using those numbers that you calculated in time 4, you should be able to show the difference between your answer in number 1 and number 4, and provide the data that you collected in order to back your answer up. To move on and talk a little bit more before we go to number 5, we'll go through some things under G. So some of the things that I thought was important was the second sentence where it says reproduction involves only one parent rather than 2 parents. The single chromosome is copied and the cell divides into 2 daughter cells that are genetically identical to the original cell. And this is the important part, unless a mutation occurs. When a mutation does occur, it can cause a new genetic trait that could equally harm or help the bacteria depending on the environment that it's living in. One example of a genetic trait that could provide an advantage to bacteria is the development of antibiotic resistance. So in this upcoming data set, you're going to see 2 different variants. You're going to see variant X and variant Y, which for me, I'm just going to tell you is just 2 different types of mutations, 2 different types of mutations. So this data set that we're now looking at here in attachment number 2, you can see variant X in the middle and variant Y on the right-hand side. You can see that they start off in generation 1 looking exactly the same. And then as time goes on, as generations go on, after they've been exposed to the antibiotic streptomycin, you can see over time what happens to generation 26. You can see that X is at 99%. You can see that Y is at 1%. Okay. And you're going to be graphing this data, and I'm going to show you how to do that. This one's nice and simple. You don't have to do the manually inputted information like we have done in the past. All I'm going to do here, guys, is I'm going to highlight all 26 of the generations. Control C to copy from my Google Sheet over here. Control V to paste. It's already highlighted, so I'm just going to insert chart, and it creates a line chart for me. And if you guys go back and you take a look at number 5, what they're asking you to actually make here is that you are expected to make what's known as a scatter plot. So a line chart's very close, but it's not the correct answer yet. So all we have to do is change the chart type. Everything is pretty much there, so we scroll down until we see scatter. And we're going to choose that selection for the scatter plot. And this is what the scatter plot looks like. The only thing that you need to add, and you guys already know how to do this, so I'm not going to model it again, but on the y-axis, you do need to add a label there. Everything else is acceptable. If you want to change the title, you can. Once again, to change the title, you go to Customize, go to Chart Axis Titles, and you can change the different titles right here. You can change your chart title there, you can change your vertical axis, your horizontal axis, etc., straight through there. So what you should see in this chart, this is just making a graphical representation of the data table that you looked at there, but you should be able to see that variant X and Y start off very similar to one another. and then over time, X is superior in comparison to variant Y, which would help you make the conclusion that with that antibiotic streptomycin being exposed to each one of those different variants, that variant X is not affected at all by the antibiotic. It allows that entire population to work, whereas the mutation for the trait variant Y, it harms it. So variant Y does not have the ability to not be hurt by that antibiotic. So hope that helps answer some questions for 4 and 5, and watch out for more videos to help out with the rest of the document.